Hi, this is Ms. Park, and this video is an introduction to trigonometry. So trigonometry is a word that's made up of two parts. The trig part means triangle, and the metry part comes from the word meter, which means to measure. So trigonometry is the study of measurements of triangles. So give you an example, we've already seen some triangles with similar triangles. So let's say again, if I use my CN Tower example, and I want to find the height of the CN Tower, and there's a shadow that's 200 meters long along the road, and I want to find this height. The only way I could do this with similar triangles is if I had another object that's shorter, that's easier to measure, and I know the height of it, and it creates another shadow which I can measure. Okay, and then I can use similar triangles. So let's suppose we have a statue that is this height. We can use similar triangles, the ratios of the two triangles, to get the missing height. Okay, trigonometry tools are handy when you're trying to get the measurement of something that's hard to measure, like the height of the CN Tower. So with trig, what I'm going to show you now doesn't require another triangle. Okay, we can work within the same triangle, but it does use the concept of similar triangles, which means a triangle that is similar to this one might look like this. Okay, let's say this one is going to be a times 2, right? Scale factor of 2. Or I could even make it bigger than that. Okay, so let's say times this, scale factor of times 3. Okay, so all of these triangles are similar. And similar triangles means it has the same, they have the same shape. So all of these angles are the same. Okay, they're all the same, even though the sides have different lengths. So if for this triangle that's times 2, this would be 400 meters. The times 3, this would be 600 meters. And whatever the h is, I don't know, 550, let's say, 550 meters, and that's going to be 2 times h, and that's going to be 3 times h. Okay, so all the side lengths are like that. Now, if I was to take the ratio of two sides in the triangle, okay, so let's say, for example, I'll take the two sides that I know. In the smallest triangle, my ratio would be h over 200. My middle triangle would be 2h over 400, which actually reduces to h over 200. And in my third triangle, my ratio of the two sides would be 3h over 600, which actually reduces to h over 200. So look what we have, similar triangles. Regardless of the size of the triangle, the ratios are the same. Okay, regardless of how big I make the triangle, as long as I have that angle the same, the ratios are the same. So that takes us to some new terminology, okay, which is called trigonometric ratios. Okay, so I don't have a second triangle for these questions. I'm going to have some information in the diagram. So that there's my CN Tower. Okay, and I'm going to have some information here. So let's say this side is the 550 meters, this side is 200 meters, okay, and the other side we can figure out using Pythagorean theorem. Okay, the first trigonometric ratio is called tan. Tan is short for tangent. Okay, tangent. And the tangent is the ratio of this. So if I have an angle down here, so let me call my angle, I'm going to use a letter that's Greek letter called theta. Theta is a letter that we use for unknown angles. So let's say I have a theta here. Then the tangent of theta, we write it like this, tan theta is equal to 550 over 200, right? And if this triangle was bigger, but it was similar with the same angle theta, then whatever the side lengths are, the ratio will always be the same as 550 over 200. So I'm just going to use my calculator. 550 divided by 200 is 2.75. So the ratios will always be the same. So if I took a triangle that was double this size, side length, the ratio is still the same. Okay, so that is called the tan ratio. There are two other ratios. This one is called sine, like this, sine. And this one is called cosine, COS, which is short for cosine. And now I'm going to draw a new picture and show you all three ratios. Okay, so suppose I have a triangle. Okay, and there's an angle theta over here. Okay, we label the sides with names. All right, this is always going to be a right angle triangle for now. So for this whole video, it's right angle triangles. Later videos will be for triangles that are not right angle triangles. Okay, so the three sides of the right angle triangle have names. This one is called the hypotenuse. We call it HYP, short for hypotenuse. And the word hypotenuse just means the side that's across from the 90 degrees. And the hypotenuse is also the longest side. Okay, we saw that before with Pythagorean theorem. The hypotenuse is the longest side. Across from the theta, we have a side called the opposite, or OPP, okay, opposite. And it's opposite because it is across the triangle from the theta. Beside the theta, there's a side called adjacent, the word adjacent. So in English, the word adjacent means beside. You can see that this side is right beside the angle. It's not across from it. It's right beside the adjacent. The opposite is across on the other side of the triangle from the theta. And the hypotenuse is across from 90 degrees. Okay, so those are important words: opposite, adjacent, and hypotenuse. And the way we do the ratios is we go like this. Sine theta is equal to the opposite, it's the ratio of sides, opposite divided by the hypotenuse. Cosine theta is equal to the adjacent divided by the hypotenuse. And tan theta is equal to the opposite divided by the adjacent. So remember, we just did tan theta with the CN tower, and it was the opposite side, the standing up side, divided by the side that was on the road. That is tan theta. So I'm going to just add some numbers here, and let's put some numbers to this. Suppose this triangle was a 3, 4, 5 triangle. So this works for Pythagorean theorem. A squared plus b squared does in fact equal c squared. So sine of theta is opposite over hypotenuse, so 4 over 5. Cosine theta is adjacent over hypotenuse, which is 3 over 5. And tan theta is opposite over adjacent, which is 4 over 3. Okay, and now we've defined the three trig ratios. If you take a calculator and pick an angle, then you can calculate sine, cos, and tan of that angle. So I'm going to show you how to do it. Okay, so I'm going to go over here. So I'm going to draw a new triangle. And this time let's put an angle over here. And let's go 35 degrees. Okay. And so let's say I don't know. So here's my CN tower. My CN tower is standing. I know I have 200 meters along the road, but I don't have this height. So what I can do is I can set up my trig ratio. So I do this. This is the opposite, so it's opposite 35 degrees. This is the adjacent to 35 degrees, and this is the hypotenuse. Right? I don't know the hypotenuse at all, but I know my opposite and I know my adjacent. And that means that I can use tan. So tan theta is equal to opposite over adjacent. Okay, that's how it's defined. And so I can say tan of 35 degrees is equal to h over 200. Now, tan of 35 degrees is a number from your calculator. So pick up your calculator, and it should be a scientific calculator that has sine, cos, and tangent on it. So look for it. Scientific calculator, okay? And you should be able to type tan and then the number, and then hit equals. Okay, so let's see what happens when you do that. Tan, and then the number, and then hit equals. Right? And I get 0.7, approximately 0.7. Now, if you are using a cell phone and not a calculator, you will need to open the calculator and turn your phone sideways, and that will open the scientific calculator. And with that one, you will need to put the number 35 first and then hit tan. Okay, but with most other calculators, you can hit the tan first and then the number, and you get 0.7. If you don't get 0.7, it might be because your calculator is not in the correct mode. So you're going to need to set your calculator to degree mode. So somewhere on your calculator there is a button. It'll either be mode or it might say DRG. And you got to press that button until you see a degrees on the top or a D. So please pause this video so you can try to get your calculator to give you an answer of 0.7 when you type in tan 35. And when you're done, come back to the video. Okay, so hopefully you're successful in getting 0.7 from the calculator for tan 35. I'm going to finish solving this problem with finding the height. So now this tan 35 is just some number from your calculator. I'm just going to leave it written like that. I'm going to put it over 1. And now we see that we have a proportion statement. We have a fraction equals a fraction. And we saw that we can cross multiply. So 1 times h is 200 times tan 35. And now in your calculator, you can do this all at once. 200 tan 35 or 200 times tan 35. And let's see what it gives you. It should give you 140. Okay, and so that tells us that whatever building this is, CN Tower or some other tower, the height of it is 140 meters. Okay, and we've just used trigonometry to figure out this missing height without needing a second triangle for similar triangles. So what did we need? We needed a side and we needed this angle. Okay, now how will you remember? So we saw that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. How will you remember which is which? So we have a little shortcut and it looks like this, SOHCAHTOA. All right, so just say that out loud, SOHCAHTOA. And what it is, it's a way to help you remember. And it means that sine is equal to OH, which is opposite over hypotenuse. Cosine is equal to AH, which is adjacent over hypotenuse. Tan is equal to OA, which is opposite over adjacent. And that's how you're going to remember them. All right, let's do another one. Here's a right angle triangle. Suppose I don't know this one. Suppose this is the one I don't know. And suppose I have an angle 40 degrees. All right, and suppose I have another side. Like let's say I have this one over here. Let's say this is 51. All right, so I want to see which of these trig ratios will be helpful to me. So from the 40 degrees, we label the triangle opposite, adjacent, and hypotenuse. All right, and let's see what we have. I know my adjacent is x, it's what I'm trying to find, so it's involved. My hypotenuse is given, so it's involved, and my angle is given. But I don't have anything to do with opposite. So I'm going to use the trig ratio that involves the angle, the adjacent, and the hypotenuse, but not the opposite. So that means I'm going to use cosine. So cosine of 40 degrees is equal to adjacent divided by the hypotenuse. And so cosine of 40 degrees is equal to x over 51. Cross multiply. I have 1x equals 51 cosine 40 degrees. In the calculator all at once, 51 cos 40, 39, approximately, 39.1. Okay, and so now I get that's my x. Okay, so getting the hang of it, hopefully. One last example. I'll do one where the hypotenuse is unknown. Okay, so let me go like this. Actually, better yet, let me turn the triangle upside down just to mess you up a little bit. Okay, now it's like this. And it's my hypotenuse that's unknown. And this side is known, and this side is, this angle is known. The other side is not. So the first thing we'll do is we're going to label the sides. This is hypotenuse. Now see where the angle is? Across from the angle is the 2, so that's opposite. Beside the angle is the side that we don't have. All right, we write SOHCAHTOA, and we look at what do we have. I have hypotenuse, it's part of the question. I have the angle, and I have the opposite. I don't have adjacent. So adjacent is not going to be involved. So I want the part of SOHCAHTOA that uses opposite and hypotenuse. So that's this one, which means I'm going to be using sine. So sine 27 degrees is opposite over hypotenuse. I get that from SOHCAHTOA, opposite over hypotenuse. So sine 27 degrees equals 2 over x. Now the x is in the bottom, but that's not a problem because we're going to cross multiply. And I get x times sine 27 degrees equals 1 times 2. And so x sine 27 equals to 2. But sine 27 is just a number from the calculator, so I can divide both sides by that number. And I have x is equal to 2 divided by sine 27, which can go right into the calculator all at once. And I get 4.4. X is approximately 4.4. And have a look at the triangle, see if that's even reasonable. Like if I got x as 400, I could look at this triangle and say, I don't think that's reasonable. Even though the triangle is not to scale, that number doesn't look reasonable, but 4.4 does. Okay, so I'm going to end this video here because this video helped us to find missing sides in the triangle. Look for another video that helps us to find missing angles. So what if we know the sides of the triangle, but we don't know an angle, right? So that's a separate video, and it also uses sine, cos, and tan, but just in a slightly different way. Okay, please practice. Thanks for watching.